one more minute. All right, let's get started tonight. So essentially what we're going to do tonight is a continuation of Tuesday night. Not really a continuation, a little bit. We're going to go a little bit more in depth into immutability and why we use it in immutable objects and arrays. And then we're just going to review. We're going to rebuild another app that is not using Redux, and we're going to use Redux in it. We can kind of see a little bit better how Redux works with that app. So the first thing I wanted to bring up, and I didn't bring it up yesterday, is that Redux, well, let's do this. Why don't we do a little review here? What does Redux provide us with? What problem does it solve? Frustration, I like that. State management, yeah, it solves some state management issues we have with vanilla React, right? It provides us with global state, a lot of overhead, absolutely. There is a lot of overhead to it. That's why we always say it's not always the right choice to reach for Redux when you first start developing an app. You really reach for it when you need it, okay? Dan Abramoff, the writer of the person that wrote Redux, famously says, and he says this actually about Thunks, but I think it applies well to Redux as well, is if you don't know if you need Redux, you probably don't, right? You'll come to a point where you're like, I need something to do this, to use, to help manage this. That's when you really feel like you need it. So until you feel like you really need it, it probably isn't the right thing to use right off the bat, right? I usually wait quite a while before I start using it in a React app, unless I have the architecture laid out really well in the beginning and I'm like, this is obviously going to need some state management. So the one thing about Redux is that it provides us application level or global state, right? It is not the only state manager. It's not the only library that does this for us. Does anyone know any other libraries that can provide this kind of thing for us? Flux, yep. So Flux is actually the original Redux. It's what Redux is based on. So Flux is kind of where a lot of this architecture comes from. And then Dan kind of took Flux, made it his own thing, put some functional programming ideas into it, made Redux. And we're going to see in a moment, we'll see tonight, really what makes Redux so special in the immutability. MobX is another one. MobX is super popular, uses observables, which if you're familiar with Angular, you'll know what observables are. MobX is, I want to say, much easier to set up, but I think Redux is more powerful. And so you could get into that. There's a couple more too. Does anyone know any more? Context, yeah. So React has the context API now, which you kind of have to understand Redux in order to understand the context API a bit. But yeah, so there is, and I don't know if it's an official release yet, the context API, but it is essentially built-in Redux for React, and where we can use a provider, we can give it what we, instead of connect, it's context, and then every component will have access to the context of the provider. So yeah, that's actually a big up and coming one, and it's still way too early to see what kind of impact that's going to have on the Redux community as a whole. There's still a lot of people that there's still a lot of people that believe that Redux and context can be used side by side. So we'll see where that goes. But if you have a great concept of Redux, you'll have a really good head start with context. There's some others, Apollo for GraphQL, Relay, which is also GraphQL. There's a bunch of these state management tools out there. Redux tends to be the one that people use the most, and GraphQL. You'll sort of learn about that when you get to backend, but it's a way of querying a database. Do they all follow the basic idea of action, reduces, and store? Nope, not at all. So they're all different. Some of them do. So Flux and Redux are very similar with that, but they're all different. So they don't follow this basic idea. I would say Redux is no, I don't want to say it's the more difficult one. I think Flux is pretty difficult. No one really uses Flux that much anymore. You might see it if someone started developing a React app 4 years ago, 5 years ago. Redux has only been around for 3.5, 4 years now. And before that, it was all Flux. So you might still see some legacy Flux. You'll see some MobX out there for sure, and it's totally different. But yeah, so just wanted to throw that out there. Just like React is not the only JavaScript front-end UI framework, you got Angular, Vue, et cetera, out there. Redux is not the only state management library to use. So it's what we teach because we believe that learning these concepts are valuable in the greater scheme of development, and that these concepts that we're teaching are not going to go away. Redux might go away, React might go away, but the concepts are steadfast and will stay with you. So that's the reason we choose to teach Redux, and also the reason we choose to teach Redux is it's got like a 90% market share in the React world. So if you're going to get a React job, you're probably going to use Redux. That being said, there are other things out there, so keep an open mind. When you get to your labs project, go look at other things. Go see what suits your project the best. Cool. So let's kind of get started. And let's go over immutability again. And we'll expand on it. But 1 second. Okay, cool. So we're going to talk about immutability, what it is in programming, right? Remember when I said yesterday that immutability is not a React or Redux specific idea, but it's a greater programming concept. And what does immutability mean in a very high level way? Who can answer that for me? What does immutability mean, or something is immutable? Unchangeable. Yep. Can't be changed. Can't be changed. Not mutating. So the word immutable comes from the word mutate. So this is immutable, whereas immutable can be mutated, right? And so let's start with this. Can this be mutated? Can I mutate this? Yeah, it totally can, right? Arrays and objects are reference bases we saw yesterday. So I can come in here and say, oh, there's 2, right? And then now I have a mutated object. I have no reference as to where this came from. Right? I have no idea where this started. For all I know, this is the first iteration of this array. I have no idea if it had nothing in it before, if it had 1,000 numbers in it before, etc. Okay, so that's one of the big parts of why we use immutable objects in Redux. if you're following along on Trading Kit, we're not going to talk about all the benefits of immutability here. Immutability has its roots in a paradigm of programming called functional programming, where we have essentially been relying on object-oriented programming the whole time here at Lambda School, whereas functional programming has some other kind of ideas that it revolves around. Very popular functional language like Haskell. There's some people do some functional stuff. Oh, Scala. So there's some bigger languages that use functional programming. Immutability is one piece of that. So the big thing, like I said, is that we use immutable objects due to predictability. All right, we can come through here. All right, and we'll go 3, and we'll say, oh, shift, and then we'll say, and then we'll run that. We have no idea where this array started from. Well, all we have is the idea of an array, okay? So mutation hides change. It changes the actual object, whether that be an array or an object. I'm using object mean both right now, but so it hides change. We don't know where it came from, and it can create unexpected side effects. So we could do something in here, not really with an array, but with an object somewhere where we can accidentally remove a key, we can accidentally add a key, we can change the type of something, and it's going to cause bugs in our code. Okay, when we enforce immutability, we keep everything simple, we keep everything structured, and it makes it easier to understand where, if I had, if I had labeled all of these, I could go back and say like, oh yeah, let me get that point in time where array 2 was there. And I know that that's the second iteration of that array. Okay, so that brings us to our second item, that why we use immutability, and that's tracking. So we can check to see if anything has changed. Where in our last, we've been with this for, I mean, even before the break, where have we seen something that matters? What tracks if things have changed? Anyone got any examples of code we've used where it's tracking to see if anything has changed? Yeah, our React state, right? If we don't use set state, what happens? Nothing, right? Because React has no idea if anything has changed. Set state actually returns a brand new object, and it keeps a reference of the old object so that it can compare the two and understand what has changed. Okay, so it allows us to track changes to our object. We can check, previous objects to the new one. We can even talk about the virtual DOM, checking the DOM, and then changing it based on that. We allow this. We use immutability to track any mutations in our state or in our object period. Okay, Redux actually keeps track of every single state that our app has been in. All right, it saves every single state that our app has been in, and it assigns it, a hash, and it gives it a timestamp, and it knows exactly when. And we're going to see this in a little bit as to what we can do. Is there a limit to the state it stores? I would say the limit is the limit of your computer. The limit of storing something internally in JavaScript. So yeah, the only limit is physical, right? but there's no set limit on Redux. But it stores it. It stores all of it. It stores our actions. It stores the types. It stores the state. And so we can actually use Redux to what we call time travel, where we will go back in time and see like, oh, we totally, and this is really, really, really good for development. We can say like, oh, we screwed up somewhere in this area. So we can go back to that area and we can step through all of our actions and all of our reducers and see what broke and where it was. It's amazing for development. You know, Redux really gets its, it really shines bright with massive code bases, with these like major, huge state trees that it's keeping track of state over all these places. You know, and so it's kind of hard to see when we're talking about it in class using a to-do app. You're like, oh, well, this is dumb. We could have just used state, right? And I would 100% use state if I was making a to-do app, a basic to-do app. So it's really going to be difficult to see that far ahead past what we're doing in class. And really, it's one of those things that has to be worked on and seen on a very large scale application in order to really appreciate it. But learning it and being able to use these little tools is a fantastic experience, I think. So let's go move on to our immutable objects now. I'm going to crush this. So let's start with arrays, okay? In order for us to write really good reducers, we need to be able to create immutable objects. And it's hard to explain until we write them, and we'll write a couple later. And I'll get into it in objects, but you know, we normally have our state, you know, we have let default state is an object, right? And maybe this object has an array in here. Well, this array needs to be, if it gets changed in any way, we need to create a new array for it, okay, in our reducer, yeah. So we not only have to create a new object, but if we're changing anything in this array, we have to create a new array in that new object as well. So we're going to start with arrays. Like yesterday, who can tell me some array methods that return brand new arrays? Slice, yep. Nap, slice, map, filter, map, filter, slice, reduce, concat. Me too. Map is, first of all, map is, I mean, if you use any kind of React, you use map more than any other array method. I love reduce. I think reduce is maybe my favorite method of all time because it just, you can do anything with reduce. But yeah, those are all array methods that return brand new arrays. So if I say something like this, right, and then I say, item plus 2. In console log R2. And I'll get all of those items, 1, 2, 3, 4, 5. And then I'll have a new array, right? And then I can also go R1, and it has not changed. So it has not changed our original array, all right? If I were to do something like for each, and I don't even have to create a new one. 3 dot for each. And then I said R1, index equals item plus 2. We're going to see that that mutates the original array, right? So for each does not return a new array to us. And we can go and mutate the original array. We do not want to do this. We always want to return a new array. And you can kind of tell that you're going to return a new array because you are assigning it, right? So if I use filter, and then I can say item. Sorry, I'm using some serious shorthand here, so let me make this a little bit more clear. So filter is going to check against this. If this returns true, it's going to leave the item in the new array. If it returns false, it's going to leave it out, right? So we're going to say item modulus 2 equals 0. So this is going to return all even numbers, right? So 2 modulus 2 is 0. It's going to return 2, 4, etc. So we can see that filter console log. Why don't we have console log? There we go. Filter is going to return a new array and not touch our original array. Okay, so being able to use these array methods is going to allow us to return a brand new array from something. Okay, what's another way? What are some other ways of creating brand new arrays? I could do concat as well. Yep, okay, so let's do that. So r3.concat r2. All right, so we have a concatenated array here where we have 2 arrays, and we still notice that. Let's go. Let's call this original. Our original has not changed, 1, 2, 3, 4, 5. Let's go use slice. Yep. Let's say so slice is going to slice whatever pieces of the array we asked it to. In this case, we're going to start at 0, and it's exclusive, so it's going to go 0 and 1. Or let me see. Is that, let's see. Yes, okay. One of them has the amount of items you want, and the other one is the, so is slice is an immutable return to new array. How about splice? Is splice immutable? Splice is not. So splice actually cuts the original array. So we do not want to use splice, right? We want to use slice. And if you are having trouble remembering the difference between the two, welcome to the club. Everyone does. So it just takes a lot of experience to remember. I still struggle every time I use splice or slice to understand what the arguments in there do. I know now that slice starts at the index you ask it to and then ends at the index you ask it to, whereas splice starts at the index and then takes a number of items you want. So splice is not. And yeah, we have anytime we see square brackets, that means we are creating a new array, right? Just keep that in mind. Anytime you use square brackets, that means create a new array for me. So we can go R1, R3, and there we go. 1, 2, 3, 4, 5, 2, 4, right? So we've created a new array, and our original is unchanged. So let's move that original down. So filter, map, reduce also returns. Well, reduce can return a new array. You have to explicitly return an array from reduce. We won't go into that super deep. But yeah, these are ways of returning a new array. And so what this really means, if we remember back to yesterday, what we're doing, what are we doing when we create a new array? What are we doing internally? Anyone remember from yesterday? The little quick slideshow I showed you? Yeah, exactly. So when we create a new array, we are creating a new place in memory, okay, for that array to live. And then we can add and remove things to that place in memory all we want, but that place in memory will always be that specific array. Whereas, so if I do something like this, what do you think this is going to console log to? Let's check it out. So it's false. So why is it false? They look exactly the same, right? That's an array with a 1 in it. Why aren't they equal to each other? Exactly, because these have the same stuff inside of it, but these are two very different places in memory. Okay, I have created two new arrays. Remember, every time you see those brackets, that's a new place in memory. So with this would be true, but I don't want to go there. So what this is doing is comparing places in memory. So, like I said yesterday, strings, booleans, and numbers all are the same places in memory. So we're going to get true for that, right? Because that is the same exact place in memory as that. That's it, all right? Same as strings. If I have a string of Dan, sorry, I use my own name all the time. It's just the first thing that comes to my head. That's true as well because those are the same exact places in memory. Okay, so you got to remember that. These are different. So that's why we don't have this. This is false. All right. Any questions right now regarding arrays, immutability, and places in memory? If address is different, then there are two different objects, irrespective if they carry the same thing. Yep, Arpita, that's 100% correct. If the memory address is different, then they are different in the scope of in the scope of are they deeply equal to each other, right? Any other questions on this right now, or do we understand why we can, if I did push on any of these, that will mutate the array, right? So this is so nice and clean. You're going to see this 99% of the time now, the spread operators. Does anyone have any questions on the spread operator and how this is working? I want to make sure that we're all on the same page right now. Yep. So essentially, the spread operator is doing this. Let's go back to R1 and R3. Spread operator is doing this. And actually, what it's doing is it's creating a slice of R1. It's adding it to an array. Then it's creating a slice of R3 and adding it to an array. So it's creating a copy of both arrays and adding it to that one array. Any other questions right now? All right. I'm going to move down. I'm going to comment this stuff out because I'll share this with you, but I want to move down to objects now. All right, so same thing with arrays, and especially objects are mutable as well. So if I had an object, and I'm going to use Alondo on here because you're the first name I saw. If I had this object and I went down in here and said, Arpita, this is mutating this object, right? So we are essentially coming into this place in memory, whatever this points to, and mutating it. So let's do a tricky one here. Let's go. Go Noah. What is name going to equal on object one? All right, I got some. Not everyone's agreeing. I love it. We got Noah, Alondo. Alondo says it's him. Noah, Noah, Noah. Let's check it out. We get Noah. Why did we get Noah? Can anyone explain to me why we got Noah? And I can explain it, but I would love to hear. Okay. Remember, going back, and actually let me pull that slide up again. Give me a second. I did not have this ready. Coming back to this slide. Let's follow this now. And actually, I just showed you, I think, a better example of this. But let's follow this. So we have created an object, right? Anytime you see curly brackets, that is creating a new object. We have assigned that place in memory to object one. Okay? So we have created a new object. We've placed it in memory as an object. We've given it a signature and address. And then we've said object one now equals that place in memory. We then said object two equals object one. So it's going to say, what does object one equal? Oh, it equals that place in memory. Okay, so these are both pointing to the same place in memory now. Object two is not equal to some weird floaty thing that object one is. They're both pointing to the same exact place in memory. So then when I change object one, what am I doing? I'm saying, go find this place in memory, right? And it's like, okay, that's it. And then change the key of name to Josh. And now object two name is Josh, okay? So in that aspect, when I created object one here and gave it the name of Alondo, let's create a new little, here's our memory. So I said, this thing right here, I'm going to create a new spot in memory for it. Boom, right there. Check. 1, 7, blah, 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 hieroglyphics. Okay. You know, it's an address here. Okay. It's a place in memory. It's saying that this item exists here, and I'm going to tell object 1 that you're going to point to that place in memory. Okay? So then when I say object 2 is equal to object 1, I'm actually saying object 2 is equal to that place in memory. So then when I change that, it's changing that place in memory, right? It's changing that object that's sitting there, so it's reflected in object 1 as well. Does that make any sense? It's hard to get over this concept that this is directly tied to object 1. It's hard. It's really difficult, I will say, to get over that concept. And I would say that a lot of professional developers have not gotten over that concept. So this is what we call a side effect. Okay, a side effect is when I change something in one variable and it affects something in the other. Okay, that is a side effect. We do not like side effects when it comes to managing state. All right, we want this to be, clear that. What we want to do is we want to say object 2 does not equal object 1. Object 2 equals a deep copy of object, or a copy of object 1. It's not deep. And now, what's going to happen when I console log object 1? Alondo, it's your time to shine, man. There we go. Look at that. Okay. And that's because, look at here, on both of these, we see that, I'm going to put this on one line. On both of these, we see that there are curly brackets, right? That means we are creating two separate objects. Now I've taken all of the stuff out of object 1 and I've put it into this one, but I'm still creating a new object, okay? Just like with arrays, when you use square brackets, you're creating a new array. With objects and you use curly brackets, you are creating a new object, okay? So it's important that we do not have side effects. It is important that we are able to track the progress of our state. This allows us to take a lot of bugs out of our programs. It allows us to understand what's happening where. And it does not allow for mutations and side effects to enter into our state, okay? So that's a quick primer on objects. So we've used the spread operator here. Times it. Almost there. We're not going to finish objects, but we'll get there. We'll get close. We've used the spread operator here. This is brand new. Like I said, I mean, it works now. It probably didn't work 6 months ago in a regular JavaScript console. So before, we would use object assign. And let's look at what object assign does. Object.assign is going to take an object and it's going to mutate it, okay? You're like, but Dan, like, we're not supposed to be mutating anything. But what we're going to mutate is a brand new object, right? So if I said 1 in here, and then I gave it some other stuff that I wanted to name, let's go food, you're going to be a pizza lover. I hope you are. We are actually mutating this object, all right? We're going to say we can actually see this. And it's going to be like, oh, it's pizza. So what we need to do for object assign is give it a brand new object, okay? Now, we got undefined because there's no food key on object 1. So we give it a brand new object to assign, and then we can give it that object. So what it's going to do, just like the spread operator in here, it's going to take all of the keys and values in this, and it's going to put it into this. That's what object assign does. And we can put, and this has to be an object. Each of these arguments has to be an object. we can put as many objects as we want in here. And we can say food, pizza. And now we got object 1, Alondo. Let's actually take this away. We'll see. Oh, let's actually remove that too. Okay, so this is object 1. And object 2. All right, object 1. So then when we come in here, now they look the same. Are they the same? Are those the same exact objects? If I went object 1 triple equals object 2, would that be true? It would not be true. Let me go to Ashley's question right now. So if you put it in an already created object instead of an empty new object in there, it will mutate the first one. Yep, absolutely. That's it, Ashley. It mutates that first object always. Okay, and then it keeps mutating it down the line. So that first object's the only one getting mutated. So just keep that in mind. That's a great question. So it's not going to like put that, if I had something else in here, which you'll see in a moment, it's not going to put this one into this one and then this one into this one. It actually goes down the order. It goes mutate that into there, that into there, that into there, that into there. Okay, cool. I think we got it. So yeah, if I went triple equals on this, we got false because those are not the same objects, right? That is a new object. We're creating a new one. And then I can do something like another object and now look. Okay, so this is probably the way you're going to see in a professional atmosphere more often than the spread operator because the spread operator is so new. But reading blog posts and things like that, you're going to come across the spread operator much more now. But I just wanted to make sure that we understood what object assign actually does. So creating a new object, and then it takes each of these, and it says, like, okay, put that one into there, and then put that one, all of the key value pairs, and it keeps going down the line. What if these share a key? I'll say I'm going to label this 1 and this 2. Which one takes precedence? Yeah, 2 will always take precedence, right? So it goes in order. The order absolutely matters in object assign. Okay, so it goes in order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, down the row. Okay, the last one is always going to be the one that matters. Okay, so if I had 10 objects and they all had a name, the 10th one's name is the one that's going to stick. All right, it's just like overriding a key. Yeah, I think, Alex, it's a good analogy to make. It's like reduce for objects, except reduce is, I think, a lot more powerful. You can actually reduce on arrays of objects. But yeah, totally. Okay, so any questions you have lingering about that, ask in Slack. Otherwise, we are going to take a 5-minute break. Why did I say 10? 5. We don't got 10. 5-minute crafts today. All right, 5 minutes. We'll see you in 5. All right, everyone, come on back. We will keep on going. Leave that up for a minute. Okay, so we now know how to create a brand new place in memory for an array. We now know how to create a brand new place in memory for an object. So it's time to combine these two things. Remember when I said if we have an object like 10, I'm just going to call it 10, like this, then doing this, let's go const WJ11. Does not create a new array. It still keeps that same place in memory. Okay, so we need, when we're using reducers, we need to also create new arrays. We saw that yesterday in our to-do app a little bit. Well, not yesterday, on Tuesday. But let's kind of go through an example that you will find. Let's go. I'm gonna get a data set out of here. Let's just use the one that's the example on training kit. And let's just say this. All right. So Ryan has given us this example on training kit. And what we want to do is we want to create a, let's write some, create a new object. Right? We want a new place in memory. This is, let's not call this my object. Let's call this old state. Okay. We want to create a new object. We want to get a sum of all the scores. There's some, so let's just do this. Let's create a new object, and then let's actually not get a sum, but let's divide all scores by 10. Okay, so let's say that our state has a name on it, and let's say it has that. And we're given this to, we want to create a brand new object all the way through. So let's actually do this. Let's say const new object equals, and let's use the spread operator because it's simple, old state, and not new object. Let's say new state. So is this going to be true or false? False, true, false. All right. Now we're talking. False, true, false, 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 true, 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 true. Yeah, let's check it out. It's true. Why is that true? We created a brand new object here, didn't we? So this is something called a shallow copy. Okay, a shallow copy is going to take the key and the value, and it's going to put it into the new object. All right. So obviously, name and name are going to be the same because Ryan is the same place, is the same string as Ryan anywhere else. It's the same place in memory. But we don't want a new array. We want All right, we don't want the old array, okay? So this only creates a shallow copy. So in this case, we need to actually change what this array is, right? So what we need to do is let's go something like, say, let new scores equal now, is this going to be true or false? We have one false vote. We had a lot of votes before. There's no wrong answer here. This can get confusing. Flip a coin, true or false. I want some more guesses, or educated guesses, or knowledgeable guesses in here. Not a number. All right, I like it. Thanks, Lee. I appreciate it. I like the honesty, Bernard. No, don't ever go with the popular opinion. Come up with your own opinion. Let's run it. It's now false. So why is it false now? Let's walk through it. Okay, we have created a new object. Obviously, we see that there are curly brackets here. We have created a new object. What this has done, what the spread operator does, is it says, I'm gonna just replace it. It's gonna go, okay, name is old state dot name. Scores is old state dot scores. Age. Oh, not it. Yeah, okay. So this is what it does. Okay. So it copies the exact values. And it's not making a copy. It's pointing to the same exact place in memory that this is. All right. So we need to create a new array for that, because we don't want to have the same array. We don't want to go through and mess up that array now. We want to have a brand new array. And so this is what we do. This is one way of doing it. What's another way of creating a new array like this? I could have done that, right? I could have done, yeah. I could have done that. Old scores, old state, not old scores. There we go. All right. So I could have used slice. Slice is like the traditional way of creating a copy of an array. I could have used the fancy new spread operator on an array. But the fact of the matter is, I needed to create a new array. Okay. So either of those would have worked. Now that I have a new array, I can come in here and say, let's go new scores dot map. Want to divide everything by 10, right? Num return num divided by 10. Okay. So now I can come in here and say, Oh, why didn't that work? Let's see. Why didn't that work? Let's talk about it. Why didn't that work? Map always returns a new array, right? We were expecting it. I was, as a lapse of judgment, expecting it to manipulate that array when it does not do that. Okay, we have to save the new array, and now it'll work. Now we have our scores. Are there any questions on this, on what we've done here? I'm sure there are questions. I would like to hear them. Or like, I have no clue what's going on. Or we've got it. Cool. It's good to hear, Lee. But for those of you that aren't, it isn't really sticking. We're using map in our own projects to date. We have not been assigning a return value. So you have been, but React automatically gets that value. So it is, if I do this, it is returning something. It's just floating in space right here. React actually will grab that. It's implied. Yep. That's a good observation, though, in that we're not grabbing it. So in React, you could do this, and then you could do something like that, right? Or you can put that whole thing in there, and both are the same. Great observation, though. Any other questions on this? Why do we care about immutability? There's a couple of reasons why. I just want to hear one. Tracking changes. Yep. One of the core tenets of Redux. I like it. Tracking, avoiding bugs. The store in Redux, the store can be changed. It just has to be assigned to a brand new place in memory. Predictability. Yep. So I kind of, jumped the gun on a little bit of this. I didn't really have a state set up very well. I could have done a better job on showing this. And we'll see that when we actually use some Redux right now. Any other reasons? Tracking, predictability. Those are big ones, right? There's one thing I said that's not on Training Kit, and it might be on Training Kit, but I didn't get it from there. What do we want to avoid? Prop drilling, yeah, well, that's Redux. Side effects, right? We want to avoid side effects. Where we saw that side effect happen when I, changed the name on one and it changed it on the other. And you're like, well, that's we don't want that to happen. We want to change the name on one, and we want to only have it affect that one, right? So pure functions, that's right. That's what it's all about. We'll get into a little bit more of that when we go into Redux right now. More Redux. All right. If there's no other questions, let's jump in. Let me save this. Saved. Share. Oh, no. Let me just get a... Come on. Oh, there it is. There, okay. Share link. Oh. Ugh. Sometimes Replit is not the most fun to work with. Okay. So that's what we just went over. I'm going to close that out. And let's come and play with this little app I built. All right, this is a really, really, really simple, basic control panel. Okay, we have what our controls are set to right here. All right, controls have been set to 0 is our count, and our color is this color. We now have controls down here where we can press these buttons to change the count, and we can use this drop down to change the color. Always Dodger blue. Come on. I like it. There we go. So let's look at what happens. We change the count. Look up here. We're going to add one, and it adds it. Okay. Subtract. It subtracts it. Change the color, and it changes the color. Mind-blowing. Okay, so it is not a super simple app, but it is a simple app, right? Let's go look at the spaghetti code of wildness we have going on in here. So we're going to come into, and I'm going to close this. Up, up, up. There we go. All right, this is our index. We are importing a controls container, a display container, and I will actually share this with you. Editor. Spaghetti code is not delicious when you're dealing with it in a professional setting, but it's inevitable. Okay, so we're importing these two containers. We're creating a class called app. That class is a class component, extending React component. So we are creating some state on this. We have a counter at 0. We have a current color. I said color. I should have said current color. I'm going to rename it current color when we refactor this. And we have a list of colors. Okay, that's all our state is. And in the long run, this is what our global state is going to be modeled after. We then have a change color method that changes the color. We have an increase count and a decrease count method that will increase by 1 or decrease by 1 depending on which one you use. That's everything that's controlling. This is all of what's controlling that application. Okay, everything going on in here is what's controlling this app. Let's go look at what we're doing in here now. We are passing the color and the count down to display container. Let's go look at that. Display container is a functional component. Doesn't need any state on its own. It's really just meant to be a display container. It's a container. It has some styles. So in this style, you may not have seen something like this before, but this is dependent on the prop. So it doesn't have state, but whatever our props are what the border of this thing is going to be. Okay? So we're going to be able to change the color of the border by whatever the prop color that comes in, right? We're passing color in. That color is going to be that color right there. Okay. We then have controls. We have a display count and we have a display color. Let's go on and display color. Pretty simple. It just is going to display a block of color depending on the props.color. Display count is going to display the count. Simple. Any questions on the display stuff right now? We're just passing our state down to this component. Anyone have any issues with this? I'd love to hear it, and I'd like to try to explain it more if you don't understand it. Props.color is right here. Okay, so it's a prop that we're passing, and we're actually going to pass it the state color on the app. So whatever that color is set to. So right now it's Dodger blue. So it's Dodger blue. And that's that border right there. Does that make sense? Cool. All right. Next is our controls container. So our controls container is going to have most of our stuff in here. We need a color. We need a count. We need a list of colors. Okay. We need a method to change the color. We need a method to increase the count. We need a method to decrease the count. Yeah, let's go back to it. Style. Have you ever used inline styles in React before? I could have done this as a style component, but I wanted to make it very simple. So style is just an object, and you can give it DOM styles. So border, border rate. You can give it any CSS style you want. It has to be a string in React. And then we can pass that object to a style prop. And it's going to use that style. Just like on the DOM, we have element.style. It's the same exact thing. Does that make sense? So you can do any CSS in here you want. But if I did, I'll just change the border to 1. Save that, come back, and now we see a border of 1. Let's come in here, 10. The weird thing about React is that it needs to be JavaScript. So you can't do, just remember when you did DOM stuff, you can't do that in JavaScript. You have to do that. And then it has to be a string as well. Let's go aqua. All right. And now we have a background color. Cool. This is like the simplest way to set styles in React. Okay. It's known as inline styles. And it actually adds them as inline styles to your DOM elements. Keep that in mind. So it overrides CSS. All right. Coming back to our controls container, we are passing it the color from the state. We are passing it the count from the state. We are passing it the colors, the list of colors from the state. Yes, be very careful with specificity. We are passing it a method to change that color. We are passing it a method to increase the count and a method to decrease the count, right? All pretty simple methods. We've seen stuff like this before, right? Let's go check out controls container. Controls container is going to do the same thing as our display container. It's going to create a style of a border around it. And then it's going to give it a couple of controls. All right, we have a color control and we have a count control. Color is going to get the color, the list of colors, and the change color. Count's going to get the count, increase count, decrease count. Let's look at our count. Pretty simple. It's going to have an on click to increase count on the plus, an on click to decrease count on the negative, and it's going to display the current count in there. So when I click minus, what is actually happening on this? Anyone follow this up? A function call, right? It's going to get passed up to here, and then it's going to say like, okay, decrease count, so it's going to get passed up to here, and it's going to say that this dot decrease count, so it's going to call this method, which is going to change the state on the app, right? We're prop drilling right now. Make sense? I'm passing props through things that are essentially have no need to understand. Which of these props does controls container need to function itself? The actual controls container, this whole component here. Without taking these into account, which of those props does this need? Color. Does it need any of the other props? It does need color. All right, we're using it for the border. Does it need any of the other props? Does it need colors or change color or count or increase or decrease? Nope, doesn't need any of that stuff. It doesn't need to know about that stuff, okay? We're just passing through. And, you know, this is a contrived example, but imagine if this was going 4 more layers deep. and keep passing these methods through and through and through and through and through. That's when you start to realize you need state management. Okay. The same thing is happening with color control. I will show this to you. There's maybe some stuff in here you haven't quite seen before. The select. This is a regular, good old-fashioned HTML. So it's going to take a list of the colors, and it's just going to create an option. And what you get out of that is this drop down. Okay, so this is called a select element, and then each of these is an option on the select. So if we look back at that, we'll see our select, we give it the current value, and then we give it options. If you'd like to read more about forms and inputs in React, let me give you a good old-fashioned link here. That's a great read, okay? And it tells you a lot about controlled components and how to work with forms. And that's essentially where we get those text inputs from. I don't want to go too deep on this. Just know that it has an on change, just like our input. How would I read the second return statement? This one right here? That's on map, right? So all of that's one thing. So we are returning something in the map function. Cool. All right, so is this a decent candidate for Redux? I'd say it does its job right now, but if we were to get any more complex than this, I would definitely start looking for state management. We're going to use this as state management because it's a lot better than a to-do. It's an okay one. I agree, Ashley. What's the first thing we need to do to bring Redux into our application? Add Redux. What else do we need? See it a couple of times on here. We need to add React Redux. We're not really using Redux unless we have, wait, what happened there? Oh yeah, we got it, okay. We're not really using Redux in React unless we have React Redux. Okay, so I, as always, am going to factor some stuff out. Just to make it a little bit more clear. Boom, 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 boom. We can actually just export default on here. Okay, and then we'll need to import app from app. Good to go? Good to go. Still works? Still works. Okay. So let me where would you start? Let me ask you that. Where would you start? You would say import create store. It's create store. So make sure you understand that it's not just store. It's a method from Redux called create store. Okay, we can do that. Oh, remember, it needs to be destructured, otherwise it ain't gonna work. Okay, then you want to import provider. And I need to do that. And remember, this is now from React Redux. Okay? All right, where are you going to go from here? You want to wrap our app right now? Okay. This is going to break. I will tell you that. Let's check it out. Do I like it? Let's figure it out. Why is this going to break? It needs a store in here. Okay, it needs a store. So what do we need to do first? Yeah, we can create the store. Well, this is going to break, right? Why is this going to break? Because we need to put a function in here. We can put a function directly in here, just for now. Cool. That should work. Oh yeah, we need to put it in there. And now we need to put our store into our provider. Okay, should work now. Okay, it's working. All right. So now that we have our app wrapped, we have created a store, we have provided a store to our provider. What's next? Yeah, I would say, yeah, we're done. Yeah, it works, right? Cool. All right, it works until I do this. And then it don't work no more. All right. That's what I want to do. I want to remove the state and I want to remove these methods. Okay, that's the end goal on this. Any advantage to putting create store into the store prop directly? No advantage at all. In fact, I would say that is a disadvantage. I like having a separation to understand what's happening. It's just like writing a massive one-line function. You know, you can do it. It's going to work. But can anyone else read it? Maybe, maybe not. I like separating things out. Okay, so the next step is to create a reducer. Let's go create a file. I'm going to call this reducer. What is a reducer? What is it? It's a function. That returns an object. Okay, yep. What arguments does this function take? It takes state and action. And that matters, right? The order matters. State and action. Can I call this blah, blah? Can I call it that if I wanted to? Yeah, I totally could. Doesn't matter what I call this. We call it state because we want to know what we're talking about. Let's do this. Right? We want to know what we're talking about, so we call it state and we call it action. I can call that blah, blah, and like boodly poo or something. I don't know. Whatever I wanted to, right? Foo and bar if I wanted. Okay? The names don't matter. What matters is what they are. All right, so this is returning an empty. Let's export this. Let's come into our index. Let's import that into here. Let's go. Let's put all of our third-party stuff in one. All right, and let's get rid of this stupid function, and let's put this stupid function in. Oh no, that's dumb. Why does it do that? Okay, still working. Still working. Cool. All right, so I'm gonna go and say the next thing we should do is model our state. We know already what we want our state to look like. How do we know that? Yeah, we already have our state, right? Right here. Let's just swipe this. I'm going to call this initial state. And I'm just going to put that in there. We have a counter, which is a number. We have a color, which is a string. And we have a colors, which is an array. All right. We're not really going to change the array on this one. So we don't really have to worry about that deep or the shallow copy. What we're going to be doing is changing counter and color. So I've got some of my favorite CSS colors in here. Why don't you guys give me 2 or 3 more? Lime. Lime better be a color. Dim gray. All right. And slate gray. We already have 1 gray. I'm going to go with 1 gray on here. Although dim gray is probably going to look white, but peach puff. All right. Okay. We're going to, of course, start out with Dodger Blue because it's the best color in CSS. So now what do we do? What's our next step here? Almost, Ashley. We're almost there. Not quite. Nope. Almost there too, Layla. Yeah, we need to set our default state, okay? So this is going to default us. So when our app is initialized, create store is going to call this function. And it is going to give us null for that. If it has null or undefined, it's automatically going to switch to that, and then we can return state. Okay? It does that on purpose. It's our fallback. Yep. We need that in Redux. You have to have that in Redux. All right. So I would say that we are pretty good in our reducer right now. So which of our components only consume data? Yeah, you can set it to whatever you want. You should have it set to something, though. So count. So any of our controls actually manipulates our data. Any of our displays. Actually, count control does. Controls counter does consume data. There you go. Okay, cool. So let's come into here. Ashley was right. Right, we are consuming data in here. We're only consuming it in here. So what do we need to do to connect this up? Import connect. Remember that we must import it as a destructured. And where are we importing this from? There we go, React Redux. And now, we're no longer exporting that function. We are now going to export default connect. Okay. What do we put in the second parens? The component name. So that's controls container. What do we put in the first parens? Map state to props. And that's all we need on this one. We don't need a default or a map dispatch to props. So let's create our map state to props. Okay, which of those items do we need? Do we need all three of them? We need the color. Do we need the counter? Do we need the colors? No. So it's very important when you do this that you don't just bring everything in, because what's going to happen is you're going to get a re-render when count changes, and you don't want that. Okay, so we only want to bring in what we're going to use. So let's say color is state.color. What's happening here when we put map state to props and connect? Who can tell me that? It's creating new props and passing it to our controls container. What is the new prop going to be called? Color, right? What if I said color foobar? What's the new prop going to be called on controls container? Exactly. It's whatever we call it here. Just like if I had come in here and said color foobar. It's the same exact thing. This is what we're doing. Okay? But we're intercepting those props and we're adding some stuff to it. So is control container going to get all this still? Is it still going to get all of these props? Oh, I have a no. Controls container is still going to get all these props. Let's actually change that. Let's go controls container. Change this to new color. Okay, so controls container is going to get all of these props still. It doesn't matter. We can still pass it props the old-fashioned way. Plus, it's going to get this new prop. It's going to get all of those plus that new one. Yeah, we're not removing them yet. We can still pass stuff to it. So it's going to get 1, 2, 3, 4, 5, 6, 7, 6, and now 7 props on it. Okay. So we put that in here. And let's look at it. Look, these are all the props. Change color, colors, count, decrease. Dispatch, we haven't talked about that. Dispatch is where we can actually dispatch our own actions, but we're using an action creator, so not worried about that. Increase count and new color. So we actually have 8. So we'll talk about this next week a little bit more. But we still get all of those props, okay? It just adds a new one to it. That make sense? What I'm going to do is call that, and then I'm going to come over here, and we'll get rid of that because we now have color. And we should still work, but it's going to display properly the first time, and then it's not going to work right the second time. We're not there yet. Where we are at is 5-minute break. So take 5, we'll come back. We'll try to finish as much of this app as possible. I don't think we're going to have enough time to finish the whole thing, but we'll get a couple of things working. All right? So let's take 5 and come on back. All right, come on back, everyone. Let's get going because we only got a few minutes and I'd like to get through this, much of this as possible. So I'm going to kind of come into our color control right here, and I'm going to worry about what we need in here right now. So I'm going to close that. Count control. We'll leave our reducer open. We'll leave our app open, and we'll come into color control. So which pieces of state does color control need? It needs the color, and it needs the colors. It needs change color as well, but we're not talking about that yet. We just need the state. What do we need from the state? So color and colors, right? Not the props, just what's on our state. We have counter, color, and colors. Does it need counter? No, it doesn't. So I'm going to kind of rush through this a little bit because we just did this. Import, connect. I'll talk through it as well. From React Redux, we're going to export default, connect. We're going to put our component into the second parentheses, and in the first parentheses, for right now, we're just going to put map state to props. We need two pieces of this state, so we need color and then this one we need colors as well. Let's put that in here. Anyone have an issue with any of that code I just wrote? All right, if you do, please speak up. Otherwise, we've just connected our state, right? So let's go check this out now. Remember that on this we added, well, let's actually come into our controls and we can actually remove those things, right? Because that was old props. We can remove those props now, color and colors. We'll still keep change color on there. So let's come in and look. Oh yeah, on our reducer, remember we added 3 new colors to it. And now those 3 new colors are here. And they actually might work, but in a different way. Works in a different way. Make peach puff and dim gray work. Okay. Oh, dim gray is much darker than I thought. All right, so we have these new colors in here. It's not working down here. Why isn't it working down here? Does anyone know why yet? Yeah, we haven't changed this actual state. So let's come and do that now. Let's make it so that we can change the color. So actually, I'm going to come into display. I'm going to also import. We need the color in here. I want it to work all the way through. Oh. Yeah, see, 2 props. I'm going to call it a little shorthand there for brevity's sake. Turn, color, state, dot, color. I'm going to do a little copy paste and bring that to our display. There we go. container. I'm just connecting up a couple of things to the color here. Like I said, if anyone has any issues with what I'm doing, please speak up. I'd love to explain it. I'm kind of rushing through something right now. All right. Now we shouldn't see any changes going on with our color. Great. That's what we want right now. We can also come and get rid of this, right? Because display color, that already has our color in it, so we can get rid of that. And we can get rid of this. And we can get rid of this. All right, we're on our way to getting all of our color stuff controlled by Redux. I can get rid of my displays now. We're not going to go back to those. They're just displaying. They're just consuming state. Okay, controls container. I don't need any change color thing in here. We need it in here. So how do I make a change color? Yeah, if you don't get rid of them, it's going to create a problem. It's really going to create a confusion in the developer's head problem. All right, Andre, so yeah, we need actions, right? So let's come in here and let's say actions, and let's create some actions. So what is an action? Well, actually, what is an action creator? An action is an object. An action creator is a function that returns an action, okay? So let's just write a function, and let's call this change color. We're going to return an action. What does an action always need? Taylor said it. It needs a type. Okay, and in this case, I'm going to call it change color. I'm going to export this. We'll grab that from our reducer, and now we can start building our action here. So our action is actually going to be this here. It's an event, right? We have an on change. So when this is changed, we want change color to be fired. So since it's going to take an event, we can add that event to our action creator. We will export the function, Brett. You're correct. So we can add a little event into here. And then we can say our payload is event.target.value. Right? So that's essentially, we're mirroring it after this. e.target.value. Payload is whatever data we want to send. So I can call this color. It's whatever data we want to send to our reducer. Okay? So we always need a type. We don't always need a payload. It doesn't need to be called payload. It can be called whatever we want. We can have as many keys and as much data on this action as we want. Right? Payload is just a generic term for the data we're sending. Well, you probably won't ever see it called payload. You're going to see it called other things, but you'll see it called payload in any kind of tutorial. Yeah, this is just an object, right? We're just returning an object. Oh yeah, if we want to do something else, name Dan. Is this fun? True. Right? It's just an object. All it is. Bernard, I would say yes. Be more semantic about what you're using and what you're sending to it. Make sense? This is what we're sending the reducer. So when we see action here, this is what the action is. Okay? That's being passed as the action. Any other questions on this right now? When we need another type, so if we need another type, we would export constant other type. We're not exporting default on here, right? And so we're going to export on here as well. We're not default exporting on any of this stuff. So we're going to need to destructure it, which we'll go do right here. So let's come in here. Let's grab change color from actions, and now we can write our switch statement. So how do I write a switch statement? First thing first, we need to write switch. Right? Yeah, it is set up very much like a function. But it has a keyword of switch. Okay, what goes in the parentheses on a switch statement? Not exactly what I should write, but what is this? Yeah, the condition, right? What we're switching, what we're basing our cases on. So I'm going to say action type. Okay, and this is going to say case if action type equals whatever we say our case is, then do this, right? So if I say case change color, what I'm actually saying is if action type equals change color, then do this. That's what I'm saying here. Okay? It's a more compact way of saying a bunch of if statements. If you had a bunch of if statements, it would still work. Okay, and then we're going to say we're going to now change our state. So let's start off by what do we do? We're going to return. And then how do we change our state here? Who wants to guide me through this? Yep. So let's create a brand new object or object assign. You can do either or. Let's do this destructuring way because, or the spread way because it seems a little bit simpler. And then we spread our state. Do we spread initial state? No, we want, remember, initial state is only our initial time. We can change that color as many times as we want, and we also want to change the counter. We also want to do some other stuff to it, okay? So we want to change the state. And when this is called, what does state equal? What is it? It's, well, okay, when it's called the first time, how about it's called the second or third or fourth or fifth or 20th time. State is, yeah, our current application state. Remember, we have pieces of our application that have no idea what a counter is. It has no concept of the counter. It doesn't care about the counter, but that's still part of our application state, right? So this is equal to our current state. So I can change the counter 100 times. The counter could be 1,000, and I have changed the color the very first time. Okay, so we always need to use our current state. And so I can even call this, if this makes more sense to you, call it current state. Okay, if you want. I'm going to call it state here because that's the way you'll see most often online. But call it whatever means something to you, and we'll remind you of what it is. And now what do I do? Action color. Remember, this is an object, right? So I need, if I'm not spreading another object, I need a key. Okay, so this is going to put all of the current state into here, and then this is going to override the color with our new color. Right? This is the same as these are the same exact things right here. That and that. They do the same thing. Any questions on that? I'm only going to return one of these, so don't ask why I'm returning two things. If I say this, is this going to work? Awful. Don't ever do this. Don't do this. All right? Don't do this. You're going to come to a point when in your Redux writing career that you're going to want to do this. You have to resist the urge. Okay? It's going to seem like the only way you can do it. You have to find a way around it. All right? So don't ever do this. Don't ever mutate the current state. Right? Always return a new copy of the state, whether that be a spread operator or object assign. Always return a new copy of the state. It is tempting. It's just easy, right? It's just like, oh, I know how to change an item on an object. Yeah, it's simple. It is. It's very tempting, and you're going to be ultra tempted by it in the future when you have deeply nested state that you have to go down and create new objects and new arrays, et cetera, et cetera. It's going to feel like, but it's not going to work. So, all right, let's move on. And let's go to our controls. Nope, not the controls. Oh, it's color control. There we go. Okay, so now we want to plug this action into our color control. We're almost there. What's the first thing I need to do? Yeah, we need to import this change color function, right? So let's do that. Okay, now that we have it, now what do I do? Add it to connect. So the second item on connect is map dispatch to props. And what this is going to do, it's going to allow us to create a prop right in line here. So we don't need to go get the state because we don't care about the state in match access to props. We don't care about anything going on the state in there. That's why we don't need to go get the state, right? We just need to get this function passed down to our component. So we give it the name of the prop and we give it what we want it to be. So I called this both the same, right? This is a key and this is that function. Okay, and I can even say something like scc func if I want it. Nope, can't do that. So that we don't have to worry about having two different names. If I wanted to, I could do that, okay? But let's just do this. Does this make sense? I know it's not gonna, it's gonna make more sense on Monday when we talk about dispatch, but this is actually going to call that function and it's going to dispatch it, whatever that returns, which is going to be an action, which is going to send it to our reducer, and our reducer, oh, we have missed one thing on here, and that's our default. And there we go. We always want a default of return whatever our current state is in case none of the action types match, just in case. All right. So now is the moment of truth. I'm going to come in here. I'm going to remove change color. I'm going to come into my app. I'm going to remove change color. I'm even going to come over here, remove that function, and remove those from the state. We didn't get to the counter. I'll do the counter, and I can share the code with you. But let's go see if it works. And it works. All the way through. All of our colors are connected now to Redux. Let's go walk through it and see what's happening now. We have a class called app. It has state, and there is no color on this state, okay? We are rendering a display container and a controls container. There is no color or change color on any of this stuff, all right? Let's go to display container. We have a props.color that we are getting from our connect function, all right? So that initial color is going to be Dodger blue. What if I change that to dim gray? Oh. Our initial color will be dim gray, okay? And even now down here. So this is our initial state. We're really only using, we can get rid of this for right now. We're really only using this, okay, for right now. Display container is connecting and getting that color. Display color is connecting and getting that color, okay. Notice that in display container, we are not passing any props to display color. We don't need to. Controls container is connecting and getting that color, right? Because it needs it for the border. We are not passing any props to color control right here. Color control is where all of our magic happens here. This is actually going to call our action and really change the color. So we don't even need the color. We need the list of color. Oh, we do need the color for our value. We also need the list of colors here. So we have a list of colors, and we can add, who wants to give me another color? Just any color off the top of your head, please. First one wins. Orange, classic. All right. So it's rendering all of those colors. No matter what we have on there, we can render it that way. All right. So this is our state. We need that list. So it's creating a list. When we select one of those colors, it's going to call this method that we have given it on our props. We have connected our props, our state to our props, and we have connected our dispatch methods to our props, okay, or dispatch functions to our props. In here, we're going to get the event, we're going to get the value of it, we're going to create an action called change color. Oops, I want to take that off because that should be like that, okay. It is connect. When we call this, connect is going to say, okay, you returned that, so then I am going to dispatch that to the reducer. I'm going to pass the reducer the current state and then this new action. The action is going to say type of change color. So we're going to be like, okay, cool. We're going to return a new copy of the state with that new color on there. All right, so we have this fully circular action, reducer, state, UI, action, reducer, state, UI. Our state, or our UI is controlled by the state. It calls actions that change the state. It's this very React-like circular pattern. I'm going to go over a couple more minutes because I want to show you something really cool. Does anyone have any questions about this right now? Let's see. How do I? There we go. Okay. There's this thing called Redux Dev Tools. You can download it on Chrome, Firefox, or Firefox. I don't think it is anything for Safari or Edge. If you're developing professionally, you should be using Chrome or Firefox right now. In the future, that might change, but those are the two you want to be on, one of the two. So I've got Chrome. Get it from the Chrome store. You'll have it where, just like your React Dev Tools, you'll have, oh, where's my Redux one? There it is. Redux Dev Tools, okay? It gives you some instructions on here of what to do, and you can essentially just copy paste this directly into your Create store. This is all copy paste. Don't worry about like what it means, right, or anything. All you need to do is copy paste it into your Create store as the second argument of Create store. Just copy paste that line in there. Now this will allow you to use your dev tools. If you are developing professionally, remove this before you publish your app to the wild, okay? So now let's open up. Yeah, I don't care about that right now. I don't know. Oh, okay. And I can open up, and you'll see it lights up here now that it's connected, and we can open our Redux Dev Tools. All right. I'm going to go a couple more minutes. What I'm going to show you right here is really, really cool. This is what makes developing with Redux so awesome. What you have here is you have all of your actions that have ever been dispatched. First, our very first thing is init. They don't have one for Netscape. Dang, man, when will people start supporting Netscape? So we have our first action, right? We haven't even done anything, and an action has already been created. Type of init, okay? So that's our initial action. That's it. That's all it is. That's what Redux gives our reducer the first thing it does. All right, let's check out some crazy stuff. There's our state. We have our state in here now. Look at that. Diff, trace, and test. We'll see in a moment. But let's start changing stuff. All right. So look, we have a whole bunch of actions that have been dispatched. All of them with the type of change color. We can click on it, and it'll tell us change color, and the color that we wanted to change it to. So this is our action. And we can look at it in raw form so we can see exactly what it looks like when it comes in. And now we can say like, oh, the fourth one, what was that? Oh, that was Dodger Blue. Let's jump to that. And now it allows us, and you can see down here, we have this timeline. Because we're using immutable objects, Redux has a memory of every single action that we have used. Okay? We can skip around our actions and see the state of our application when that action took place. This is time travel. Okay? This is what we're talking about when we say, yeah, you can say like it happened somewhere in the between 1 and 2 seconds, right? Like, okay, well, it's got to be one of these. So let's start at this one. We'll jump to it. And then let's go forward, each one. Oh, that's where it messed up. Now we can go in and see exactly what our action said. We can see what the state of our application was at the time. We can see the difference between the old and the new. You access previous Redux action history within the code. Well, I'm sure you can. I thought you meant like if I refresh this, then that's all erased. Okay, so there's no way that anyone can like spy on you or anything using that stuff. And this is really for development purposes only, just in that we, just like React DevTools is for development purposes only, right? Our state still works. That's kind of crazy, huh? Because state doesn't matter. And now we can come in here, and yeah, look, we got our diff, trace. Okay, I'm not going to do that. So we can say like, oh, what did it change from and to? Change from Blanche Almond to dim gray in this one. We can go back and say like, oh, this is when it changed to Blanche Almond. It's really, really cool stuff. It allows us to develop and get a really great idea of how our code is working and where it's going and where it's been and what caused different state changes to happen. Like I said, this is one very minor thing. I know for a fact. Let's go. It used to be that Replit did not turn their DevTools off. And we can see like the actions that they're using. Sorry if we're going way over time here, I apologize. Feel free. Oh, what is going on with Replit? Come on. Feel free to go and work on your assignments. But this is cool stuff. If you want to see some, what is happening here? Oh, they might have done something weird. You used to be able to look at Replit's actions. Go download and get DevTools, and if you see it light up, open it up and see what kind of actions they're using, what their state looks like. It's going to be crazy. I'm going to go find something and share them with you. So that's it for tonight. I hope that it's been a little bit more eye-opening. My computer is lagging. Hope it's been a little bit more eye-opening and made things a little bit clearer. I'm going to finish this up and I'll share it with you so you can see the other actions and a more robust reducer with actions that are controlling that count as well. But if you have any questions, throw them into chat. But other than that, have a great night, everyone. I will see you on Monday. And yeah, enjoy Redux some more. Have a good night, everyone.